Okay, so now we're going to look at the quotient rule. And these are easier to see for most students because if you have one function divided by another function, that's a quotient. And it's usually easy to see by looking at it that it's a quotient. So here's some examples of a pretty simple quotient and another pretty simple quotient. The third example is trickier because it has a product in the denominator. So the third one again has two choices. You could FOIL together the denominator and then do the quotient rule, or you could have the product rule in the quotient rule. So I'm going to show you both of those. So here is the quotient rule. So you can see why I did the arrangement I did where I had VU prime and UV prime, but in the quotient rule, there's a minus. So it's the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all over the bottom function squared. Every time you do one of these problems, you're going to see a v here and a v squared here. You cannot cancel this. And it has to do with the fact that you're subtracting something else off, and the subtraction has to happen before the dividing by v squared. So it's going to look like something that could cancel. Never cancel that. Okay, so let's look at the first example. I have the u function is the function on the top, x minus 2x squared. Then the v function is the function on the bottom, 4x squared plus 1. Okay, now let's do u prime is going to be 1 minus 4x. And v prime is going to be 8x. So now we're going to do our diagonal multiplication. So I'm going to have 8x times the x minus 2x squared. And remember, the order of the multiplying doesn't matter. And then I'm going to write out this multiplication because I don't want to try and do it on the fly. I'm going to write it out and then do it. So that is the bottom function times the derivative of the top minus, forgot which thing I was doing, minus the top function times the derivative of the bottom, all over the bottom function squared. Now this needs a lot of algebra simplifying. So we're going to FOIL and get 4x squared minus 16x cubed plus 1 minus 4x. And then make sure you distribute negative x and get negative 8x and get negative 8x squared plus 16x cubed. And that's going to be over 4x squared plus 1 squared. And you're never going to multiply this out. It is simplified. Okay, factored is simpler, so don't ever multiply out the denominator. It will make your life harder, not easier. Okay, so let's see if we can find any like terms. Oh, look, here's negative 16x cubed and 16x cubed. Sweet. Okay, now here I have 4x squared and negative 8x squared. So that's going to be negative 4x squared. Then minus 4x plus 1 over 4x squared plus 1 squared. And this is my derivative for example A. It can't be simplified anymore, and we're done. Okay, so let's do example B. And we're going to do the same setup where we have u, the top function, is 2x minus 1. And v, the bottom function, is 4x plus 3. Okay, then we're going to do the derivative of u is 2. And the derivative of v is 4. So we're going to have 4 times 2x minus 1 when we multiply diagonally. And 2 times 4x plus 3 when we do the other diagonal multiplication. And we're going to have a subtract. And then we're going to divide by 4x plus 3 squared and label that as g prime of x. Okay, so let's do our algebra and get 8x plus 6 minus 8x plus 4 over 4x plus 3 squared. And our 8x's are going to cancel and give us 10 over 4x plus 3 quantity squared. So that is our derivative. Okay, then let's look at example C. And I'm going to show you the product rule way because that's what I wanted to demonstrate here. So the top function is u equals x cubed minus 1. Then the bottom function is 4x minus 1 times 3x plus 7. That's our v function. Well, now when I go to do the derivative of the v function, I need the product rule. So let's do the u function's derivative first, 3x squared. Well, now the v function, I'm going to have the derivative of the first function is 4. The derivative of the second function is 3. So I'm going to have 3 times 4x minus 1 and 4 times 3x plus 7. And I'm adding these because I'm doing the product rule on this product of two functions. So I'm going to have 12x plus 28 plus 12x minus 3, which I'm going to simplify to 24x plus 25. So now my numerator of my quotient rule is going to be the v function, 4x minus 1 times 3x plus 7 times the 3x squared minus the u function, x cubed minus 1 times the v prime, 24x plus 25, over the denominator squared. And remembering that you can either put the squared on each of those two factors in the denominator or keep it like it is. Depends on if you have something that might cancel. So let's see what we've got. I'm going to FOIL here and get 12x squared plus 28x minus 3x minus 7. And that still needs to be multiplied by 3x squared. And I'm going to have minus 24x to the 4th minus 25x cubed plus 24x plus 25. Sorry, I ran out of space there. And then what I was saying earlier is you can use the product rule of exponents and write this as 4x minus 1 squared times 3x plus 7 squared, and that sometimes will make it so things will cancel. I don't know in this case. So let's see, I've got 36x to the 4th when I distribute the 3x squared. Then I have 25x's, and I'm going to distribute the 3x squared. So that's plus 75x cubed minus 21x squared minus 24x to the fourth minus 25x cubed plus 24x plus 25 all over my denominator. And we're almost there. Let's combine our like terms. Looks like I have 36x to the fourth minus 24x to the fourth, leaving me with 12x to the fourth. Then I have 75x cubed minus 25x cubed, so plus 50x cubed. Then minus 21x squared plus 24x plus 25, all over my denominator. And you would not be expected to try and factor a degree 4 polynomial. So this is your h prime of x. Okay, then I want to do one more example of find the equation of a tangent line. So I'm going to make some space here. Okay, so recall that finding the equation of a tangent line involves finding the derivative. So my top function is x, and my bottom function is x squared plus 2. So my derivative of my u is 1, and my derivative of my v is 2x. So then I'm going to do my crisscross multiply and get 2x squared, and the other crisscross way, x squared plus 2, and those are getting subtracted. Sorry, keep my mind on what I'm doing. All over x squared plus 2 squared. So that's going to be negative x squared plus 2 over x squared plus 2 squared, and that is f prime of x. So it should be labeled up here too. Here is our answer. So that's our derivative at any point. So when x equals 2, we need to use function notation and say, now I'm going to find f prime of 2. So I'm going to have negative 2 squared plus 2, and that negative is not inside the parentheses. And then 2 squared plus 2 squared. So I'm going to have negative 2 on the top and 36 on the bottom. So that's going to reduce to 1 over 18. And this is m of the tangent line. Okay. So m is negative 1/18. So now I need to find the y coordinate of a point so that I have 2 comma some y value. So I use the original function to do that, and I use my function notation to show that's what I'm doing. I'm finding f of 2 to find this y coordinate of the point. So that looks like 2/6 or 1/3. So there's my point that's on the graph of the function and on the tangent line. So now I can write the equation of the line, y minus 1/3 equals negative 1/18 times x minus 2. And we can write this in slope-intercept form. Y minus 1/3 equals negative 1/18 x plus 1/9, and then add 1/3 to both sides. Get y equals negative 1/18 x plus 4/9. So let me encourage you to draw the graph of x over x squared plus 2 on Desmos, and then draw the graph of this tangent line and see visually what's happening there. And then I'm going to pause this video here and come back and do the last little bit.